previous class we have discussed about dispersions of light through a prism. We found that when a white light passes through a prism, then it's split it into 7 colors, and those 7 colors we found as VIB0, that is we have discussed. And we also discussed, in case of their wavelength and the refractive indexes of those 7 colors, how they behave once it passes through the prism. Today we're going to discuss a very important and very interesting and beautiful topic of ray optics, with which we are very familiar, that is your rainbow formation, one of the finest creations of nature, and basically one of the finest creature of sunlight. Okay, that is belongs to the natural phenomenon, some natural phenomena due to sunlight. Understand? So you all know when the rainbow form after rain. Am I clear? After rain, it occurs in the sky opposite to the direction of sun. That means directions of rainbow and sun will be opposite to each other. And you have to stand, your sun should be behind you when you're observing the rainbow. A rainbow is basically consists of 7 colors, and all of you know what are those 7 colors. So let's discuss the one of the finest topic of this particular chapter, that is formation of rainbow. The topic is formation of rainbow. Formation of rainbow. So how rainbow is formed? First of all, you should know what is the definitions of rainbow. To kindly write down the definitions of rainbow. What is rainbow? You can write, you follow me. It is a phenomenon. It is a phenomenon of sunlight. It is a phenomenon of sunlight that occurs in the sky. In the form of bow when sunlight falls on a tiny drop of rainwater. This is the definitions you can write, that is in case of rainbow. It is a phenomenon of sunlight that occurs in the sky in the form of a bow when sunlight falls on a tiny drop of water. You can write it tiny droplets of water. Tiny droplet of rainwater. That means once the sunlight will be incidental, will be falling on a raindrop, then the raindrop will behave as a prism. As you know, how does prism behave? Once the white light falls over it, it's split it into 7 colors. The same criteria is also going to be happen in this formation of rainbow. What I'm saying, that tiny water droplet of rain will behave like a prism, and once sunlight will fall, that particular light will be split into 7 different colors. Okay, that is how we can also find the rainbow. So write down this rainbow. In case of rainbow formation, we'll have 3 processes basically. That is, first process will be your dispersion. Second process will be your total internal reflection. Followed by again refraction of light. So these 3 processes through this process a rainbow is formed. That is dispersion, total internal reflection, then again refraction. These are the three processes through which we go once the rainbow is formed in the sky. First is your dispersion, second is your total internal reflection, and third is your again refraction. Am I clear? So this is the basics about rainbow. And rainbow is also classified as two type of rainbow. You can write types of rainbow. You write the types of rainbow basically mean that it is two types of rainbow. Okay, rainbow is how many types? Rainbow is of two types. That is, one is primary rainbow, and another is your secondary rainbow. Like that we can classify that rainbow will be classified as primary rainbow and secondary rainbow. So in this regard, what is the difference between rainbow, primary rainbow and secondary rainbow? Step by step we'll learn. But let me inform you what is primary rainbow. Say we are having two rainbow in the form of bow like that. This is the first, this is one rainbow, and I have taken one more rainbow in this. Here, this is one more rainbow. That means we have taken two rainbow. Now, if I say that this is primary rainbow, suppose this is primary rainbow, and this is secondary rainbow. So, what is the difference between primary rainbow and secondary rainbow? Can you tell me one? Anybody? So difference is nothing than how many colors generally we find in case of rainbow formation. It is 7 colors. As you know that those 7 colors were, if I write from this side, this is P0. Am I clear? So above this is red color and below this is your violet color. So in case of primary rainbow, the upper color will be red. Understand? And in case of primary color, the lower color will be violet. But in this case, in the secondary rainbow, it will be opposite. The upper color will be violet, where the lower color will be red. The basic difference between the primary rainbow and secondary rainbow. So in this case, the upper color is red, lower color is violet. And in case of secondary rainbow, the upper color will be violet and below color will be red. Is that clear? So why it is happen? Because in case of primary rainbow, when the sunlight will be falling on a raindrop, it refract for one time. It refract for one single time. But in case of a secondary rainbow, it will be what? There will be multiple reflection, that multiple time of reflection and multiple time of refraction. Not multiple time, as you can see, there will be two time of refraction, or there will be two time of reflection. That means there will be refraction will be twice in case of secondary rainbow. Refraction, then as you can see, the first of all at the beginning there will be dispersion so far. Next will be there will be two time of total internal reflection, and finally refraction. That is the difference. But in this case, the refraction will be only for one time, and this is their spectrum of color. Red will be above, violet will be below. Here this will be complete opposite. So we'll discuss today in this class about the formations of primary rainbow. Next class we'll go for secondary rainbow in brief. Let's write down the formation of primary rainbow. Formation of primary rainbow. You can write here formation of a primary rainbow. Primary rainbow. Just note the headline. Now how does a rainbow takes places. As I told you, that sunlight falls on a teeny water droplet. So if I make the water droplet like that, I am making it bigger so that we can observe everything what is happening. Okay, so this is the water droplet that is spherical. Basically water droplets are spherical in size. Now if I consider this is the rainwater droplet, or if I consider that a ray of light has been incident on it, this is the ray of light that has been incident on this particular raindrop. Okay, this is, suppose you can say this sunlight. This is sunlight, and sunlight has been incident on this rainwater droplet. This is your water droplet, you can write down. Now as you can say that when the ray of light will be traveling, the medium will be changed. Okay, in the interface of it, this will be your water medium, that is denser medium, and this is air medium, it is rarer medium. That means light is traveling from rarer to denser medium for sure. Now once light travels from denser to rarer medium, what happens you all know. Apart from that, I told you that when ray of light will fall on this tiny water droplet, then this water droplet will behave like a prism. Once a white light passes through a prism, then what happened? The prism splitted the ray of light in different colors. So in this case also, same procedure will be happen. That means the ray of light will be splitted in different colors. Am I clear? Like that, the ray of light is going to split it in different colors as prism does, and raindrop is behaving as a prism. So this is the sunlight, as it enters in the water droplet, it's split in the different colors. So this color, as you can see that this color has been deviating less. As you know that this will be red color. This will be red color because red color deviates less because its wavelength is high and refractive index is less. Understand? And the violet, this is violet color. This color is going to be deviated maximum because its wavelength is less. Its wavelength is going to be less, but refractive index is maximum. As you know, we have discussed in the previous class. Understand? So once once this particular change happen, again what will happen next? This ray will again reflect back. This will be, that means if I make this is normal, suppose somewhere this is the normal. If I draw this normal, and here also this is the normal. Most probably you have got it why I have made a normal here. For a special case I have shown the normal. Now this is angle of incidence, this is angle of incidence. If this angle of incidence become greater than the critical angle, basically it happens. If this angle of incidence becomes greater than the critical angle of these two medium, then it will get reflected. That will call your total internal reflection in this point. This is angle of incidence, this is also angle of incidence. If it is got bigger than critical angle of the medium, then it will reflect back. It will be total internal reflection, like that. This is going to be your total internal reflection. Is that clear? And similarly, this ray is also going to be bent. This is a red color, and this ray is also going to be bent, violet color. Bent means it is going to be again total internal reflection. As you got it? So this is violet, again this is red. Who is deviating much? Violet is deviating much and red is deviating less. The reason I have told you. And what is this process? This process is going to be your total internal reflection. So the normal will be like that. This is the normal, somewhere this is, and in this case also this will be the normal. As you can see that this is angle of incidence, this is angle of incidence, and this is, both this angle of incidence are going to be greater than critical angle of the interfaces. This is this particular procedure, this phenomenon. From here dispersion has start, and here total internal reflection has start. Again, once it coming out from the raindrop, then it will be refraction, like that. Again it will be what? Refraction of light. This is red and this is your violet. Have you got it? How many processes will take place in this case? 3 processes. That first, in this case, very beginning, in this point, there are what? Dispersion. There are dispersion. In this point, there are total internal reflection. Again, in this point, when light is coming out from the raindrop, that is again refraction. That means number 1 process, number 2 process, number 3 process. Total 3 process has taken place in the formation of the rainbow. Now in this case, this violet color will be making an angle with this particular relevant ray of the light, and this angle will be 40-degree angle, and red color will be making an angle, and this angle will be 42-degree angle. Remember, the red color is making with this particular ray an angle of 42 degree, and violet color is making an angle of 40 degree. Am I clear? So like that, once an observer will see like that, suppose these are the raindrop now. How does observer will see? That's what I'm going to tell you. These are some raindrop. Okay, these are the raindrops, and somewhere here, this is the observer. This is what? This is the observer. Now observer, how observer will see a rainbow in this case, in case of the formation of primary rainbow, or how does an observer will see the primary rainbow? Okay, so it's very simple. Now once there is sunlight, these are sunlight coming through, these are sunlight, these are coming through in this case, and once it falls on the raindrop, then what will happen? From here there will be 2 rays will come. Understand? There will be 2 rays will be coming from here. This is 1 ray, and this is 1 more ray. Let's make it a little bigger. This is 1 ray, and this is 1 ray. This ray will be violet, and this ray will be red. Understand? And this is what? This is your teeny water droplet, and this is the sunlight that is being incident on it. Understand? Suppose observer is being here. This is the observer. Again, 1 more ray is coming like that. Suppose like that, this is falling somewhere. So from here also, the ray of light will come, and the ray of light will come like that, and this will be your violet, this will be again red in this case. Now this violet and this red color will not be visible to the eye, observer's eye. What observer will see? This red color and violet color clearly. That means you will see that the rainbow that is forming in front of his eye, that in the above, that is red color, and in the below, that is violet color. Okay, as you found that in case of primary rainbow, the above color is red and below color is violet. Have you got these things? This is how a primary rainbow occurs in the sky. And in case of primary rainbow, there are 3 processes. One is dispersion, total internal reflection, followed by refraction. Is that clear? So this is how it takes place. And this is all phenomena. This particular phenomena of bending of light or dispersion of light, we can take the concept from prism. Okay, so this is how it will see, like that. After all, we can conclude by saying this, that once uh, sunlight falls on a teeny raindrop, then the raindrop behaves like a prism. Okay, and once the sunlight is incident on it, then first of all the ray of light disperses. That means it's split it in 7 different colors, and after that again total internal reflection takes place in this point, as this angle of incidence becomes greater than the critical angle of that medium. This is second procedure. Again, lastly, when the ray of light are coming out from the raindrop, then again one more phenomenon takes place, that is your refraction. That means three processes. Here, this is dispersion, this is total internal reflection, and this is again refraction. But in some books or some very famous author want to say that total internal reflection does not occur in the formation of rainbow. This is still a controversy in physics, but we'll come later to that things. We'll discuss briefly about that. And finally, this is your formation of primary rainbow, and observer will be able to see like that fashion. Okay, I hope you have no doubt. You can make your notes on also, or you can inbox me. I'll send the notes for it. For today, thank you. In the next class, we'll study about the formation of secondary rainbow.